Hello everyone, welcome to Roots of Unity. I am Marzukh and today we will continue vectors. For this video, we will cover the scalar product. A scalar product is also known as a dot product. It has various implementations, but the two which are in the scope of the P3 syllabus are finding the angle between two vectors or lines, finding the foot of a perpendicular. Okay. So what is a scalar product of vectors? Well, consider a vector A and vector B. The scalar product would be A dot B equals to this. Okay, notice the dot? Hence, it's called the dot product. Now remember, this is not actually vector multiplication, but it's a different operation. So, this is the modulus of vector A, and this is the modulus of vector B, and this is the cosine of theta, theta being the angle between the two vectors. This is a geometrical interpretation of a dot product. Well, algebraically, we can calculate the dot product by summing the product of the corresponding entries. That means, for instance, if vector A is equals to this, and vector B is equals to I plus 2j plus 3k, then the dot product will be the sum of the sum of the product of these corresponding elements. So it will be 2 into 1 plus 3 into 2 plus 4 into 3, which is equal to 20. This is where the first implementation comes. Suppose these two vectors are drawn and we want to find the angle between them. Then we can do this by using both the geometrical and the algebraic method of dot product. Well, we write A dot B is equals to modulus of A times modulus of B times cosine theta. We can calculate the A dot B, which we have already done, which is 20. We can calculate the modulus of A and modulus of B. Modulus of A is root over 29 and modulus of B is square root 14. Now all we need to do is find the theta. We make theta the subject and cosine theta, cos inverse theta, and voila, it's done. Theta is equal to 6.98 degrees, rounding it off to one decimal place would give you 7 degrees, 7.0 degrees. So now, if we know any two vectors, we can always calculate the angle between these two. Now, what if there are two such vectors such that the angle between them is 90 degrees? Then A dot B will always equal to 0. This is because in the geometrical interpretation, we have the cosine theta, right? And cos 90 is always equal to 0. So regardless of the magnitude of each of the A and B vectors, the dot product will always equal 0. Now, this is the key aspect of the second implementation. Alright. So let's say this is the point A and this is the line R. Let's just move that. Yeah, this is the line R equals to C plus lambda D. The foot of the perpendicular from A to this line would be the point F on this line, such that the vector AF is perpendicular to this line, as in it makes 90 degrees. Now we know that the dot product of AF and the direction vector in this line is equal to 0. This is because AF is perpendicular to the direction vector of this line. Now, if we know C and D, we can easily calculate the point F. Alright, let's do an example. So it's given a line's equation is R equals to I plus J plus 5K plus lambda times 2I minus 2J plus K. Find out the coordinates of the foot of the perpendicular from the point A, 1, 2, to this line. Alright, great. So let's briefly draw it for better visualization. We don't have to be accurate about it. So roughly this is the point F, which is the foot of the perpendicular line drawn from A to the line. Now let's find out f. F is basically the point on this line, right? So it's a point on this line for a certain value, a specific value of lambda. So if we just simplify this, it's actually 1 plus 2 lambda I, 1 minus 2 lambda j, and 5 plus lambda k. Alright, let's calculate AF. AF is equals to OF minus OA. OF is the position vector of F, OA is the position vector of A. Let's calculate this, and we find out AF to be 2 lambda, minus 2 lambda, and 3 plus lambda. Alright, great. Now, let's calculate the dot product of AF and the direction vector 2, minus 2, 1, which will give us 0, because they're perpendicular, right? So let's calculate this. And as we can see, an equation forms with the parameter lambda, which we can now solve it. Let's solve it. And we find lambda is equals to minus 1 by 3. Let's now plug this value of lambda into the coordinate of f, the position vector of f. So it's 1/3, 5 by 3, and 14 over 3. So the coordinate f, the foot of the perpendicular, is 1/3, 5 over 3, and 14 over 3. Okay, so that covers the 2 implementations, and we're done. Alright then, see you in the next video, guys. Bye!